Hey everyone, in this video we are going to discuss about MQTT message format. So we will see what is meant by MQTT message format and what is the general description for that one, and in particular what will be the format when we are making the subscription to the broker or when the subscription is being acknowledged. That is when the broker is sending an acknowledgement saying that your subscription is successful, or when we are connecting to the server or when we are disconnecting from the server. So what are all the message formats we will be seeing in this video. So before that I will request you guys, so if you are new to the channel, please guys hit the like button and subscribe the channel for more updates. Okay, so moving on. So as I one thing I want to say is, already I have made a videos on MQTT. So what is mean by MQTT and why it is used in IoT basically. So what are the differences between MQTT and HTTP. So all those things I have covered in my previous videos. So if you have not seen that videos, please guys first see that videos, then watch this, it will be effective. So I have seen lot of videos are there but they are not as much clear. So for a common student to understand those videos is difficult. So what I did is I have simplified the content. Okay, so message giving telemetry transport is lightweight publisher subscriber network protocol. So as I've shared, MQTT is a type of publish subscriber model where to a particular topic you will be subscribing so that the data will be provided to you by the broker. So its name is message giving telemetry transport. Okay, so that is also called as MQ telemetry transport. Okay, so now coming to the message format. So this is the general format which you will be seeing everywhere. So the first bit, so there is a total three parts in the message format. So the first 2 bytes will be the fixed header, that is they will be present in all type of messages, and the next byte, that is the y plus x bytes, is the remaining length. So that will be the addition of variable header and the payload. So variable header is something which is not always present and payload is also not always present. So these two points are optional or bytes are optional, whereas the first 2 bytes are always present. So the first 2 bytes are again divided into 2 bytes. So the first byte contains command type. So what is meant by command type and what is meant by control flag will be seeing in next slides. Okay, so this is the first 2 bytes will be the control header here, and remaining length will be the addition of variable header and payload. So variable header is used to give some additional information like client ID and what is the topic name, and payload is basically the data which we want to transmit from or publish or receive. So payload means the actual data which we want to transmit. So if you are publishing some temperature to the broker, then payload means let us say 30 degrees Celsius is the temperature, and variable header contains the topic, that is temperature is the topic here. So temperature will be present in variable header and 30 degrees Celsius will be present in payload. So they will both form the message of the publisher, so that can be sent to the broker. So this is the general diagram. So as you can see, remaining length here is the addition of these two, variable header and the payload. So variable header is x bytes and payload is y bytes. So the addition of these two will be x plus y. So this is the general diagram which we can draw. So I have given explanation over here. So what is meant by, first we will see command type. So the first 4 MSB bits indicate the command type. So this is totally 1 byte. So this is the 1 byte and remaining length will be 1 to 4 bytes. So I have written here. So this is related to 1 to 4 bytes, that is remaining length. Okay, so the first 1 byte is divided into command type and control flag. So command type is of 4 bits and control flag is of 4 bits, because 1 byte will be equal to 8 bits. So 8 bits are converted to 4 bits and 4 bits. So first 4 bits are for command type and second 4 bits are for control flag here. So that totally form the control header. So the first 4 MSB bits indicate the command type. So what is meant by command type? So command type is something where you tell the broker what type of command you want. So basically MQTT is something where you will be sitting here and the broker is sitting, means you will be sending an command, then the broker will be sending an acknowledgement. So that's how the MQTT protocol works. So for every message you send, there will be an acknowledgement which will be sent by the broker, that confirmation. So acknowledgement means basically the confirmation itself. So that's how the MQTT protocol works. So that's why we need a command and a broker acknowledgement from the broker as well. So if this command type value is equal to 1, that means we are sending a connect message, or we are willing to connect to the broker. So a client may be subscriber or the publisher or the subscriber. So these two falls in the same category, that is client. So if you want to connect with the broker, then you need to send 1 in the value of command type. So in command type we have to put value 1. So how I can write 1? So I can write 1 in terms of binary bits as 0001. So first 4 MSB bits will be filled with 0001. So this indicates when the broker sees 1, then it comes to know that the client is trying to connect with the server, so that is broker. So that's why if you put 1 here, then it is connect. And then for publish the value is 3. So if you want to publish some data to the broker, or if you are a sensor and you want to publish the data to the broker, then you need to put value 3 there. So how I can write 3 in terms of binary? 0011. So when I write this and when it sees the value is 3, then the broker or the server comes to know that the client is trying to publish some data, so it is ready to accept the data, or it will send an acknowledgement based on that. And similarly for publish acknowledgement, so if you are publishing some data, say temperature, and how do you come to know that my data is reached the server or not? So it has to send an acknowledgement saying that yes bro, I have received your data or the temperature. So okay, so then you can remove your tension from of being that one. So publish acknowledgement is something, its value will be 4. So for connect it is 1, for publish it is 3, for publish acknowledgement it is 4, and for publish receive, then it is 5 here. So similarly a lot of things are there, so you can google it for more information. Okay, so now the second 4 bits are for control flag bits. So here I am talking. So these are the control flag bits which are allocated 4 bits here. So what is the significance of that? We will see now. So these are particularly used by publish command. So whenever you are publishing to the broker, at that time only these are used. That is the next 4 bits, that is LSB bits of the control field. So for others these are reserved and their value will be equal to 0. So for others their value will be equal to 0 here. So these are the last 4 bits of the first byte, that is bit 3, bit 2, bit 1 and bit 0. So this is from MSB to LSB. So this is the LSB and this is MSB. So what are all the meaning of these bits? So the bit 0 indicates, tells whether the published message is retained message or not. So if this bit, that is the last bit LSB, is kept high, at that time the end node, that is client, is saying that please retain my message for further. So the broker will be storing this message if this bit is equal to 0, that is bit 0. And if bit 1 and 2 are high, denotes the quality of service, that is it 0 or 1 or 2. So to indicate the quality of service we are using bit 1 and 2. So quality of service meaning is, if quality of service is set to 0, then at that time the client will be sending the information only once. So whether the broker will receive it or no, it will not acknowledged. So here the broker is present and here the client is there, so it will be sending the data once. So it will not receive any acknowledgement from the broker saying that I have received your data. So it is just like a shoot and forget situation, where you will be sending the data but you will not bother anything about reception of that data by the broker. And one indicates only So it is acknowledgement basically. So when we send the data, you will be receiving an acknowledgement from the broker saying that I have received. So it will be at least one type of condition. So if one time it fails, then it will try for a second time. So that is QoS level 1. And in QoS level 2, it is similar to the QoS level 1, where the acknowledgement will be received, but it is only one. So second attempt will be not there in case of QoS level 2. So once it will send, and it will ensure that the data is received, and it will receive the acknowledgement as well there. So most preferable will be the QoS type of 0, because however the data will be sent, so it will be assumed by the user. Okay, so next, last bit 3, it denotes if the present message is the duplicate message or not. So let us say this is the broker and you are here, so you are a publisher, so you want to publish data, that is temperature. So you have sent already 28 degrees Celsius, and but you are not sure that this message was received by the broker. So you are sending the data again in order to play a safety pin. So at that time, what you will be doing is you will put this pin as 1. So it indicates the broker that it may be present that this data I have already sent. So if you have this data already, then please discard this data and keep that data well. So if you don't have that data, then please add this new data to your database. So that is basically like a safety player there. So this is how the control flags are classified, that is bit 0, bit 1 and 2. So okay, so now the next byte is the remaining length, that is its length will be x plus y, that is the length of variable header and the payload. So what is the significance and what is the meaning, we will see now. So we have remaining length over here. So this is the addition of variable header and the length of the payload. So as I already said, this will be the addition of variable header and the payload. So its size will be varying from 1 to 4 bytes here. So where each byte uses 7 bits for length and remaining MSB bit is continuation flag. So each byte is having 8 bits, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this MSB particular bit will be used for continuation. So this will be used for continuation, and to indicate the number, only 7 bits are used. So that I have written here. So to indicate that the next, so this is 1 byte and this is 1 byte. Okay, this is 1 byte and this is also 1 byte, to indicate that this second byte is the continuation of the present byte. So to indicate that, we need to put 1 here, so that it will understand that this whole thing is the it is one family, that is it is the same. So it is the continuation of the previous bytes itself. So to indicate that, we need to put 1 here. So if you have another byte here, then we need to put 1 in this MSB. So to indicate that next byte is the continuation of the present. So that's the meaning of using an MSB bit to indicate or continuation flag. So if continuation bit is 1, it indicates next byte is continuation of the previous byte. So as I said, it is same thing there. And if it is 0, then this byte will be the last byte of the length. So if I put it 0, then it will not consider it as the part of this one. So it will assume this byte is the end of the message or the length. So let us take a quick example here. So if payload length is equal to 2 and variable header length is 2, then what will be the remaining length? So obviously it will be the addition of these two. So it is equal to 4 here. Okay, so now the next byte is the variable header. So it is of length x byte. So it is not fixed. Its length can vary from message to message. Okay, so what is meant by variable header and what is its general format, we will see now. So it is not a mandatory field in MQTT, so it may or may not present. So as I said earlier, so it is not an mandatory. So it may be present in some commands or messages, and it may not be present in some other messages. So its general format is something like this. First, it will be containing protocol name. Its length will be 2 bytes. So it will contain first thing as the protocol name. So its length is 2 bytes and then followed by the protocol name. So how much is the length of this protocol name is indicated by the number in the protocol name length. So similarly protocol level. So this protocol level is something where the version of the MQTT comes into picture. So if you are using the MQTT version 3.3.1.1, then the code for that one is 4 here. So 4 indicates version 3.1.1. So similarly for 2.1.1 the code is 3. So protocol level indicates the version of the MQTT which is being used by the client. And connect flag, basically this is to will message, so its value will be generally 0 to here, so that indicates the willing message, so that the client want to connect with the broker. And keep alive is to uh, keep the connection alive for a particular time period. So if you want to keep the connection for a let us say 60 seconds, then you need to enter the code 003C here. So it will understand that the client want to make the connection alive for a period of 60 seconds. So if in between you send some other message, then the keep alive time will be renewed and it will be starting from that point, it will be up to 60 second again. So like this, if 60 seconds are elapsed, then at that time the session will be cleared and the connection will be disconnected. So that's how the keep alive works. So example MQTT. So for example, if the variable header contains the MQTT as the protocol name, so at that time what I will be entering is length is equal to 4 because it has got 4 bytes here. So the 1 2 3 and 4, so this is the protocol name and this is indicating the length of the protocol. So basically these two boxes are there. And what is the significance of protocol level? So as I said earlier, it determines the version, and connect flag, it determines the will message, and then keep alive for 60 seconds. To make the connection intact, we need to enter the code 003C. So for different time periods it is different code, so you can google it for more information. Okay, so now the next thing in our general message format is the payload. So what is mean by payload, we will see now. So the payload, it is also not a mandatory field, means not always present. So it actually holds the data to be published or data to be transferred. So as I said earlier, it is not mandatory and it holds the actual data to be transferred to the broker. So it may be from publisher to subscriber or from subscriber to the client as well. So its general format is something like this. So it first contains the client ID length. So a client or publisher or a subscriber, so he is given with a particular ID to identify with what is the name. So as the humans are given with a name, so these nodes are given with the client ID here. So that length is of 2 bytes. So that 2 byte will be the length of this client ID. So there the length is indicated. So the broker has to know what is the length and what is the length of that ID. So there 2 bytes are used. Then client ID will be given here. So next field is the username length. So it is also of 2 bytes and username will be followed by that one. Then password length is there and that will be followed by the password. So it will be something like length and its name, length and its name, length and its name. So that is client ID, username and password. So for secure communication we need all of these, that is client ID, username as well as the password there. So let us take a quick example of a payload example. So this is the real world example. So here first two bytes are for client ID, so these two indicates the client ID length. So client ID length is 3 here. So the what is the client ID? So I have taken XYZ. So this is up to this point. Now username length is of 2 bytes, so first byte and second byte. So username is ABCD, so it will fill up 4 here because 1 2 3 and 4. So we came up to this point now. So password length is of 2 bytes. So again 2 bytes are allocated for password length. So password is 1 2 3 4 and 5. So 0005. So 5 will be filled up here. So this is how a payload will be present. Okay, so now we have not seen an example on variable header. That is, we have seen a general format for this one, but we have not seen the a real world example. So this is how a real world example will be looking like. So here the length will be there. So as similar to the payload. So length will be then followed by the protocol name. So protocol name is XAB, so length is equal to 3, and protocol level it is 04 means version 3.3.1.1 we are using. Then connect flag will message will be 02 always, and then keep alive for 60 seconds. So we need to enter the code 003C here, so to make the connection alive for 60 seconds. So this is our variable header example will be looking like. Okay, so until now we have discussed all those things, that is command type, control header, variable header and payload. So we have discussed them separately. So now we will club them together and we will see a complete example how it will be looking like. So it is there. So how a practical published packet look like. So this is for published, and for connect, for disconnect, for acknowledgement, it will be something different for, but just this is the mostly used type of packet. So we are using this one. So first what it will be containing, control header. So control header is this one. So control header contains command type and control flag. So its value is 30. So command type is 3 here and control flag is 0. So this is 3 and 0. So it is put all together in a 1 byte, it will become 30. So 3 indicates the command published and 0 indicates continuation flag, that is reserved, that is for publish it is not used. Okay, so remaining length is equal to 13 here, because the length of this one is 13. So you can count these, it will be 13. Okay, so now, sorry, it will be not 13, actually it is 19, because when we count these two bytes, that is when we add the bytes of variable header and payload, it will be 25. And as the numbers are in hexadecimal, we have to subtract 6 from this one. So we'll be getting 19 here. So I have to make this 19. So sorry for that one. So okay, so the variable header contains the that is first the length of the topic name. So what is the topic? Topic is my channel name, that is it actually. So the number of bytes which are used by this one is the C here, so that is nearly 13 bytes bits I can say. Then the payload contains the length of the message, that is 9, and the message is please guys subscribe. So subscribe is the message which is being sent under the topic is it actually, and please guys, if you are new to the channel, please subscribe. So the remaining length field will be 19 here. So this is how a complete message will be looking like. And similarly, if you see for a subscribe packet, so for subscribe packet the command type is 8, and except subscriber, for any other it will be 0. So for it will be 2. So for subscribe the value of this, that is control flag, will be 2, and for any other it will be 000. So any other if you take, then it will be 0. So remaining length, it should be calculated depending on the variable header length and the payload length. So here I am sending only the, so here it is a broker and you are a client here. So you are a subscriber, actually you want to subscribe to the broker, then you need to send a message. So this is my ID, so I need to send my packet ID, that is this is my name, I want to subscribe to you. So that is length of the subscriber. So this is the packet ID I'm sending here. So that is also the variable header. So in variable header itself, we will be sending the packet ID. So that's why I said variable header size is not fixed, it will be changing from message to message. Now you see, it is containing only the packet ID, it is not containing anything else. So as I said earlier, it was containing too many things, but now it has not it has got only the packet ID as its component. So now this is the payload length and name. So payload length, it is 10 here. So the topic to which the subscriber want to subscribe is the temperature. So this particular subscriber is willing to subscribe to the temperature as the topic. So what are the temperature changes at a particular environment, it want the subscriber want to know. So it will be sending as a temperature. So what are all the temperature changes, or the what are all the temperature data I want to know. So it will be sending the temperature, and this last field indicates the requested QoS. So QoS is the quality of service. So QoS means that it has indicated 00 means so only once I want to receive the data. So that is I don't want to send any acknowledgement. So that is QoS level 1, 0 or 1 or 2. So I have said earlier. So what is the meaning of these individual QoS levels? So like this, a complete subscriber packet will be looking like in a MQTT protocol. Okay, so this is all about MQTT guys. So I hope you like this video and found it useful. So if you have any suggestion or feedback, please guys leave it in comments. So I will answer surely. So thank you. Thanks for watching.